In this lesson we're going to look at the reaction of halogens with the alkenes. Now we remember that when the halogens reacted with the alkanes, this was a more complex reaction. In order for that reaction to take place, we had to break the bond of the halogen molecule using ultraviolet light, and then a rather complex free radical chain reaction took place. Now in the case of the alkenes, it's a different situation. Because the alkenes have got this carbon-carbon double bond, that makes them more reactive, and the double bond helps the reaction with the halogens to go a lot more easier. Let's just imagine we've got some alkenes, perhaps that we've collected from a cracking experiment where we've been cracking long-chained liquid paraffin into short-chained alkanes and some alkenes, and we've collected the alkenes in a test tube. So let's say we've got some alkenes from the cracking experiment. Now there is a tutorial on this experiment which you can also have a look at. Okay, but let's suppose that we've got alkenes here, and we're going to react these alkenes with some bromine which has been dissolved in water. So we've got bromine water, which has this characteristic orangey brown colour. So we'll remove the top from the test tube, we'll add the bromine water, replace the top and gently shake it around a bit, and we'll see that this orangey brown colour decolorizes or becomes clear depending upon the concentration of the bromine water. And that has happened because the alkenes have reacted with the bromine to form haloalkanes, and we'll write the equation for that in just a minute. So we can say here that the solution decolorizes or becomes clear. That depends again on the concentration of the bromine water, and that is the result of this reaction. So in this particular case we've got ethene reacting with bromine in the bromine water to produce dibromoethane. Okay, the di means two bromines onto an ethane molecule. So let's just finish off by writing the symbol equation. C2H4 plus Br2 goes to C2H4 Br2. Okay. So the fact that this orangey colored bromine water is decolorized or becomes clear depending on the concentration means that this has become the classic test for the presence of the carbon-carbon double bond. Now that carbon-carbon double bond could be present in ethene or propene or any other alkene.